Good morning, good afternoon, and welcome. I'm very pleased to be joined by Yuval Bachar, who is the CEO and founder of ECL. ECL are doing an interesting approach in the hydrogen world, certainly a unique one that I've seen, which is creating hydrogen-powered data centers. So welcome, Yuval. Thanks for joining us.
Thank you for having me.
And so, yeah, tell us a little bit about ECL. I know your name came up in our research for the World Hydrogen North America event, which is taking place in Houston, 15th to 17th of May, and hopefully you're going to be there in attendance. And so, yeah, tell us a little bit about ECL. It'd be good to get an understanding of how did you come across the idea of using hydrogen to power data centers, and exactly what is the data center market like? We certainly see it as a rising star in terms of electricity consumption globally. But yeah, give us some of your thoughts and background to the company.
Yeah, so ECL came to the data center world to create a new category of data centers. ECL is creating a new category of data centers which says data centers can run fully sustainable, zero emission, zero water use, and be community integrated instead of community disruptive. We built ECL after many years of experience with very large data center operators in co-locations and as independent private data centers. And we took technologies which were existing, like fuel cells, etc., integrated with novel technologies that we created for cooling and optimizing ability to actually create a highly sustainable, but also a highly efficient data center. We integrated the hydrogen in a safe way, and we're actually taking precautions to make sure that our site is actually safer than having diesel generators. But with that, we were able to eliminate completely the need for diesel generators. We eliminated completely the need for UPS systems in our data centers. But we did a data center which is actually highly available, with 6 nines of availability without connecting to the grid. So most of the grids in the world today are not clean green grids. Most of the grids are actually coming from fossil fuel and coal. And we are basically bypassing that step. We are creating an independently self-powered data center, which is running from hydrogen. Now, we are striving to get green hydrogen in everything that we do. And that makes our whole cycle sustainable. Data centers are continuing to grow at a pace which is exponential. That trend cannot be stopped or delayed because there's a real need in the world for services that come from those data centers. If it's data services, if it's banking services, if it's any kind of commercial services, health, everything is associated with what those data centers are doing. So we'll have to figure out a way to do it. And at ECL, we made a conscious decision that we will actually create a data center in 2023 that will going to be fully functional on hydrogen with zero emission, zero water. And like we said in our announcement, when we came out of stealth in Q2, that site is going to be up and running in Mountain View, California, and then replicate it to a significant number of customers that we have right now around the world, not just in the US.
What's the sort of scale of your initial, pilot plant or the Mountain View project?
Yeah. Our whole solution is based on modular blocks. The blocks are actually structures, they're not containers or anything like that. Each block is 1 megawatt of IT, which just to give a feel, it's about 3,000 to 4,000 servers can be in every block, or probably 200 to 500 machines, which are AI machine learning machines. And those blocks are replicated. We were able to optimize the cost of those blocks to the point that when we go to a larger site, when we build a 5 meg, a 10 meg, or 25 meg, we do not need to consolidate the blocks. Each block stays independent. And that value is actually enabling us to be able to run a multiple solution that will actually grow as you need for the customer. You don't have to pre-commit to very large site, but you're going to enjoy from the first megawatt to the last megawatt, the cutting edge capabilities that we have and the sustainability. We took this approach because we believe that people need some time to actually get adjusted to this new technology. It's not something that will happen overnight. We don't expect it to happen overnight. So if you give the customer small blocks to actually grow and create an incremental plan, say we'll build 3 right now, we'll run with it for 12 months. If we're happy with it, we add another 3 or another 5 or another 8. That model works very well and resonates extremely well with our customers.
And in terms of supply, I mean, I assume you have to store a certain amount of hydrogen on site to give you backup power, if that's the right word, or to give you, security of constant power. How much are you looking to store? What are your thoughts on that? Does it depend upon the country you're operating in, and therefore the risks to? Well, I suppose it's always an island. It's always an island anyway. So I guess it has no bearing about the stability of the grid, because you're not using grid electricity.
Exactly. So we are holding on site 5 days worth of operation, and we bring either refueling every 5 days, or if we're connected to a pipe, we are constantly pulling from the pipe. We don't need a refueling cycle. When we go larger, each one of our blocks are actually requiring a refueling at max capacity every 5 days. Most data centers do not operate at 100%. They operate at about 65% load, which means that the refueling cycle happen every 10 to 12 days and not every 5 to 10 days. And in that case, we make larger sites and still limit the number of refueling cycles that we need if we're doing external refueling. If we are connected to a pipe, then the size of our data center is unlimited, and we don't have a refueling cycle because the hydrogen is flowing into our site constantly.
Yeah. And in terms of data centers, it's not a world I know a lot about, but I assume they are going to be more dispersed. We've seen legislation about the location of data being in certain domiciles or certain countries. So they're spreading out outwards as the internet gets bigger and bigger. And are they also going off grid? So are they just being connected via satellites, and so they don't need to actually have an electricity connection, and you can locate them in cold places or places which are secure, I guess?
Yeah, so you're absolutely right. Data centers are becoming more dispersed and less centralized, and there are multiple reasons for that. I think the main reason for that is data sovereignty. There's a very strong requirement from different states to actually maintain the data in their area and not move it out, in and out. So you will see, instead of very large data centers, which are being used right now to centralize services, to actually smaller sites which are put in other places. Those sites are being put in places which are less centralized. As a result, they have less grid availability because less power is available in those areas. So being off grid gives a tremendous advantage and tremendous time impact, because connecting to the grid anywhere, no matter at what level, takes between 18 and 24 months. Operating off grid means we can build our site in 6 months. Now, with regards to connectivity, network connectivity depends on where you are. Now, most of the network connectivity you see in the data centers is fiber-based, so it's not satellite. Satellite is not giving us enough bandwidth at this stage to address mid-size data centers. We'll have to create fiber connection. Fiber connection is everywhere, so there's a lot of fiber in the ground. Part of the value of ECL is that when we select the sites, we look at multiple layers of selection. One of the layers is fiber connectivity. The other layer is availability of hydrogen. The third layer is the friendliness of the community we're coming into and how much they're willing to work with us. Because we are contributing back to them. We give them water back. We generate water on site when we generate energy with hydrogen. And we definitely have more water than we need. We give it back to the community that we're in, hot water and cold water. So we enable them to use hot water if they need to heat areas around us, and cold water for anything else that they need, irrigation or anything else that we need. That's part of the beauty of using hydrogen. When you generate energy with hydrogen, the byproduct is water. And that is something that's also becoming scarce in a lot of places. So being able to actually produce water as a byproduct is also tremendous value in working with generating energy from hydrogen 24/7.
Fascinating stuff. So yeah, certainly been very interesting to talk to you and get that sort of brief overview on ECL. Certainly a market to look out for, and certainly ECL look forward to the launch of your hydrogen powered data center and tracking this sector with some interest. So many thanks, Yuval, for taking the time out to share your thoughts with us today or this morning. I know you're early there on the West Coast. As I said, we hope to see you at Houston in mid-May at the World Hydrogen North America Congress. And yeah, as I said, we wish you success with ECL. Certainly going to be an interesting market.
Thank you very much. And just to summarize, we will change the world of data centers, and it's a hydrogen is a tool in our toolbox to make sure that future data centers for future generations will be carbon neutral, carbon free, and water free. And we are weeks away from actually demonstrating it for the first time in the world.
Excellent. Well done. Many thanks.
Thank you.